All right, so welcome back, everybody. This is the continuation of the Java on Lego. How do I say it again?
Legos?
No, not Legos. We learned earlier that it's not, the plural form of Legos is Lego.
Just say Lego.
on Lego, Raspberry Pi, and other embedded devices. I have with me Gary Collins, who is one of my coworkers and co-conspirators at Oracle. We do lots of playing with devices and hacking on stuff. And he actually is the most knowledgeable person I know about different development boards and kits and devices and all sorts of cool hardware embedded stuff. So it's an honor to have Gary here today.
Thank you for having me. Yeah, I get a lot of toys, or I call it work. But really, it's toys and get to have fun and play with devices.
Yeah, you should see his cluster. You walk in, and there's like racks and racks of embedded devices on shelves,
they're on the mail
blinking
slots.
lights.
Yeah. Because they're small.
It's like a supercomputing cluster, but a miniature one in his cubicle.
It works well.
So let's talk a little bit about how, because you deal with lots of embedded devices. So how do you go about like picking devices or?
It's the basic thing with, when you're trying to do embedded programming, first time and getting your feet wet, so to speak. You've never done anything on embedded or a really small device, even a Raspberry Pi, for instance. One of the things when you first try to design an application, you want to deploy. I want to build this new gizmo to do something, but a lot of times people stumble upon at the beginning of trying to define the system they're going to run on instead of just working on your Java code and then redefine your system later. So basically, what I usually go with is, find a known processor type that, is relatively supported. Know your basic memory needs, but exceed them. Don't limit yourself in the memory at the beginning. Local storage needs, graphic needs, OS, different types of OSs, drivers, kernels, and things like that. You should not have to really worry about those things, but just have them in your back end of your brain. But where it starts at the beginning is build on experience. More times than not with testers in Oracle, when we have to try doing Java on all sorts of different types of CPUs, I try to start with Linaro, Debian, Ubuntu, and et cetera, to try to choose which board are they supporting. Because I don't want to have to go and build U-boot. I don't want to have to build the kernel. I don't want to have to build all the device drivers. And I don't want to build the bloody OS. So I just want to have something that actually I can get up and go and run and forget about the system and actually just do some Java programming. So basically, that's kind of the biggest tip, if I can say anything, is go look at what the Linux community is supporting and be careful of the community. Look at what Linaro, Ubuntu, Debian, and what they're using, and not try to go with the build it your own kind of like, oh, follow this Yocto instructions on how to build. Believe me, it's painful. I've been doing this for, I'd say, about 10 years. And I used to have to build the kernel. I had to build the U-boot. I had to build the trusted boot server.
You don't enjoy doing that?
At the beginning, it was just, I got lots of gray. I don't know if you can see, but that was pretty much caused by that.
Yeah.
So here is a list of the dev kits that, you can go to this site and look at all sorts of different types of dev boards that are out there today. There is a way more today than when this was first generated. You can look at the small Linux
No, the market for these sort of small devices is exploding. So all the manufacturers are putting out iterations over iterations over iterations of new dev kits and boards, and it's very confusing to get started with.
Yeah, and that's why we talked about the Raspberry Pi, though, what they showed, it's pretty much a real simple board and easy to use. These are other board devices. So we can go through a couple of boards that I actually have in the lab. I actually absconded them before I left.
All right, so I'll hold devices for the camera, and we can talk through them over the table.
Sure. Where do you want to start? Form factor.
Yeah.
So we'll go from the biggest computer, I guess, so to speak.
Oh, that's a monster.
So here goes Steve. Will pull that up. This is a Freescale board. It's an IMX6. They call this the Sabre platform-based system. It's a quad CPU, quad GPU. It's 1 gigahertz, 1 to 2 gig, depending on your configuration. It's got a couple of cameras. It's got GPS. This thing has the bells and whistles. When you pick a system, you want to pick your base system to have all the bells and whistles. Why? Because it's easier to basically program from a device that has all these things than to later try to add on different things later. You know, when you want to add a new contraption, how do I do that? Well, most of these dev kits have all the bells and whistles you can possibly imagine, and you're not going to use them all, but that's okay. It gets you up and going really fast.
So what sort of processor does this guy have?
This is the IMX6, Freescale's newest GPU.
How many
CPU.
megahertz?
So this is 1 gigahertz. It's 4 CPUs.
Cool. How about the GPU? What's the GPU? on this?
It's a Vivante GPU, and I think it's a dual.
Dual core GPU.
Yeah.
Nice. And memory?
This one has 1 gig.
So this is like shopping for electronics for embedded geeks.
I consider this an embedded platform a super rich platform. This is an awesome platform.
So how much would one of these run me if I wanted to buy one for my kids?
Yeah, that one there's not really a kid-friendly one. It's $1,000 for this one.
Ooh.
But
okay.
it has all the bells and whistles, the GPS, it has the stuff for the SIM card and all the things that you could possibly imagine.
Okay, so this is the one I asked my boss to buy for me.
Yes, that's what I did. So
Cool.
that's one board. So, you know, for the rest of us folk that, you know, can't afford these $1,000 ones, there's another new version that they have out.
Here,
Steve will hold it up. So this one here is a Sabre Lite, just the board itself. This is an IMX6 quad. Same thing that this thing had, the other board had. Same spec pretty much. Everything that it has. This is $149. The display is another $100 or so, but it has all the things you can possibly imagine on a device.
Yeah, no, it's a really nice small form factor, except for this monstrosity of a stacked USB Ethernet.
Yes, I know. We actually thought about putting that inside the original Duke pad, but we realized that this thing would be monster thick, so we ended up going with
the Raspberry Pi. I think that was a good choice.
Yeah.
Yeah.
So
it's almost exactly the same board spec-wise. It's just
yeah, it's got
smaller form
Ethernet,
factor,
USB.
cheaper, fewer connections.
It's got a SATA disk, which is cool.
Wow.
Having the SATA disk, I don't know if anybody played around with SD cards. The write performance and read performance are pretty horrific. But with a SATA disk, it bypasses that performance problem, and it's much more reliable. Or systems that have eMMC. I don't know if anybody heard of what eMMC is. It's basically embedded memory on the system. It's kind of like a flash memory, so to speak, and it's relatively fast.
I found the SATA controller. It's this one right here, right? This guy, the port.
No.
No?
That's the power for the SATA.
Oh, where's the SATA?
SATA's right here.
Okay, so Gary's corrected me. There's SATA power, the white one over here, and then the black one over here is the actual connectors for the hard disk.
Yep.
That's pretty cool. Okay.
So that's that board.
So I can possibly afford one of those, but
Yeah,
my
that
wife
one-
would not let me buy it for Christmas for the kids.
So that one's pretty reasonable. So before that board came out, there was this other board from Freescale. So why am I choosing Freescale? Well, it's not so much Freescale. What I try to do for testing Java, because we need to make sure that the JVM actually runs really well and is very reliable. Freescale, we've been using their systems for a very long time. Their machines, I call them bulletproof, so to speak. You know, you can throw everything at it and it doesn't die. So this one here is a Freescale IMX 5.3. It's a quick start board. It's what it's their first impetus to get into a system that you can actually get up and going really fast. And so this one here is a 1 gigahertz single core, 1 gigabyte of memory. And why I like this one over some of the other lower memory systems, like I said, more memory is better, because then when you've got a test environment, they're running GC tests that are doing massive garbage collection and stuff. You want to have a little bit more room and footprint to handle all the different types of situations that's going to be thrown at it. So I call that a really rich desktop platform.
What are these serial connections for on the side?
Those are for remote debug.
Oh, okay.
Serial tip.
Oh, so that's how they hook up the
Yeah,
serial tip instead of the
yeah,
they're
good
better connectors then.
So the most important piece in your arsenal of toolbox is this guy here. This guy here is a USB to serial adapter. This thing is your big friend. If you don't have one of these when you start doing embedded development, it's, you know, I think it has this IP, or I don't know why it isn't booting. The U-booter isn't booting. Typical Linux, anybody know how typical Linux boxes boot up? Anybody? Grub bootloader? The serial console or the console information comes easily to you on a normal x86 platform. On these systems, they don't. So you actually have to use a serial tip to connect onto the console or the TTY port and capture the data so you actually can see what's going on, like get the IP of the machine because it doesn't have a head. So this is usually your really good friend for bringing up systems, doing customizations of the boot environment to tell it to, like Steve said earlier about the display on the Raspberry Pi, we can actually change the U-boot environment to tell different attributes of the display or the Ethernet or such. So that's that board.
So I was just thinking, you were mentioning serial tips, and I think I have a Pi serial tip sitting around somewhere, but it looks similar. It has connectors for the GPIO pins, but then ends in a USB end.
Yeah, I actually have one right here connected to the Raspberry Pi.
Oh, yeah.
So it's on this board right here, and it's right here.
Yeah,
so
I'll hold it.
That connects right into my USB port on my Mac.
Yeah, so right here.
Yep.
So that's a nice way to debug the Raspberry Pi when you can't get network connectivity or figure out what's wrong with the boot process.
Yeah, and this one's a 3-port. So you can get the 4-port one with the voltage as well. So it can actually feed the voltage from your Mac if you got a reach enough one that can push out beyond 0.7 amps. Then you can actually power the Pi and everything right from the serial tip port as well.
Cool.
So anyways, so that's that board. Oh, so a different form factor. So we're still in the Freescale family. This is like one of the original systems that they came out with. This one's an IMX 515. Had all sorts of issues with the graphics being relatively reliable on the X11 stuff. But
it looks like a little netbook.
yeah, it's basically a little netbook. It's ARM Cortex. It's Cortex A8 processor inside, 512 megabyte of memory, and it's 800 megahertz. It's reasonable.
Yeah.
So you see what else we got here for toys? This guy here.
Oh, now this looks very different.
So
this
you
is
guys
not your
were
typical
doing the
embedded device.
yeah, you were doing the digital signage.
Yeah.
So this is Marvell's early version of one of their systems that they had. Anybody hear what a Shiva plug is? Yeah, got some people who know what a Shiva plug. So Shiva plug, Guru plug. Marvell makes a system. Well, actually, Global Scale makes a system with their chips, and this is a Global Scale Shiva plug, so to speak, with a display port. So it actually has an HDMI port on this thing. It has a bunch of USBs. So if you rotate it towards the camera,
HDMI.
So there's the HDMI port on this thing here. It has debug ports as well. It has micro SD slots for it for memory cards.
Side, right?
People use these for gateway servers, file servers.
And then more on the bottom.
Cool video jukeboxes, so to speak, connected to your TV. These things here are absolutely bulletproof. We have 100 of these are roughly running 24/7, running hundreds of thousands of tests a day. And these things have not died in, I think, the 7 or 8 years that I still have systems up and running. So that's those ones. So how many people heard about a BeagleBone Black? Yeah, so it's another new device. Well, not a new device. TI. This is made by TI. So TI has been doing ARM boards for quite a long time. I'm sure a lot of people are familiar with it in the old microelectronics days. But anyways, this thing here is their newest version. They originally had the BeagleBone systems, and they had different revs of those. Then they went to the BeagleBone XM. Then they went to the BeagleBone Black, or white, then black.
Yeah.
But they also have a PandaBoard, which is a multi-core system. So this one here is a Cortex A8 processor inside it, whereas the PandaBoard that they have which is Cortex A9.
Yeah.
And that's dual 1 gigahertz. This one here is, I think 1 gigahertz and 512 mega memory. So if it was me testing, I would choose this board over that board because it's 1 gig of memory, and it's just much easier to run with testing.
Yep.
So cool.
Oh, we got capes. We got capes
yeah,
to work with this.
So I think, Steve was talking about people making their own devices. So somebody in the community that was using BeagleBone wanted to build a cape. So they wanted to have a Wi-Fi cape. This is actually a Wi-Fi cape with Bluetooth. And so they just plug this on top of the BeagleBone, and they become a cape. And you can layer these on top of each other. So there's the Wi-Fi on top of the BeagleBone, and here is
Okay.
the battery cape.
Ooh,
So this
that's a big one.
supplies power to the system. So you can basically put this thing out somewhere, wherever you want, and let it run, do some sensor monitoring or something. And the community behind this is pretty good, actually really good. A guy that I usually rely the most upon for a lot of the TI stuff is Robert Nelson. You can just Google Robert Nelson and BeagleBoard, BeagleBone, IMX6. The guy has his fingers in everything. He helps make my job actually much easier, and actually your job much easier. So just Google around for him. He'll definitely help you out in that.
Cool. Well, that'd be handy to have for Raspberry Pi, so I don't have to carry around USB power supplies for it.
Yeah, exactly. So one last board, I guess, or actually two more boards. So this one here. So this one's another vendor, ST Ericsson. So they created a board called Snowball. This one's a Cortex A9. This board here is really a cool board. This has an accelerometer in it, has a GPU, gyro in it, has Bluetooth, Wi-Fi, you name it, it has it in it. And it was $199 roughly for that board there. But I think, I believe they're discontinuing making the boards or something. I'm not sure, or the division got bought by somebody. I believe that's what happened.
I like the Pelican logo.
Yeah, it's pretty cool. So what else we got here, Steve? Oh, so when we were talking about convergence and ME getting, and
Yeah,
SE
yeah.
kind of combining. So this is a board that you would typically run a low-end ME version of the JVM on.
Oh yeah, the Kyle board.
Yeah,
They make a bunch of different types of boards though, right?
absolutely. And not just them. I mean, Freescale makes a lot of
Yeah.
different types, kinetic systems. I'm not really into those too much yet. I just started getting this board. Actually, I just got this board. I
Yeah.
just opened the wrapper today, so I haven't really...
Fresh out of packaging, you can smell the. Oh,
So I haven't...
nice electronics.
Yeah. So I haven't really done anything with it yet. So that's boards. Oh, wait, one more. So I hate to say one more, but this is another one. Believe it or not,
This doesn't look much like a board though.
that is an embedded system. So that system there has a dual GPU for graphics, Mali 400. It has dual Cortex A9 CPU inside it. So it's 1.2, I think, gigahertz. It's got, I think, 1 or 2 gig, 2 gig, I think, of memory, and an eMMC of either 8 or 16 gigabytes of memory.
Wow.
So this thing here is an HDMI plug. You can just plug it right into your port of your TV.
So is this designed for like TV applications?
Yeah.
Like
Digital signage.
yeah.
Absolutely.
Yeah. No, this would be really nice form factor.
It's got Wi-Fi in it.
Wow.
Yeah, so it's...
And it looks like it has USB on this side. So is
Yes.
that USB for connectivity and power, or just power?
No, that's for connectivity. So you can
Okay.
actually add different devices.
then power it off the HDMI?
There is a power on one of the side ports. Flip it over. There it is.
Oh, there.
Yeah,
Okay.
and then it also has an micro SD slot. So
Got
that's
it.
pretty much, I think, the smallest, Java SE compliant ARM system that you can run on.
How much do these cost?
That there is, I think, like $79 or $60.
It's small, but it's much more powerful than the
Way
Pi.
more powerful, yeah, than the
Yeah.
Pi.
Cool. Okay, so I got my Christmas list
Yeah.
for Larry.
Exactly.
That's pretty cool.
So those are boards. So Steve was talking about the Legos, or whatever you want to call it. Anyways, we were talking about different contraptions and attachments. Those attachments for the Lego part is reasonably, I guess not really reasonable. They're like $35 to $50 a piece for each one of the add-on modules and different things. So I brought a couple of different types of things. So we were talking about Angela's light sensor or something.
Yeah.
So this is just an off-the-shelf, you can either try to build your own, or at the beginning, you can just go buy a light sensor that's already working, USB, and it connects to the system itself in the USB port. And this is from Vernier. And this system, it just captures light intensity. And this here is $150. So the Legos is sounding a little bit more reasonable.
Yeah.
So
What's
on my board,
yeah.
though, I have another light sensor, which is right here. This light sensor here is $1, and this analog to digital converter is like $10. So with a Pi and everything, you're at $50, and I already got my first little, test case to run Java on and play around with inputs and outputs.
Mm-hmm.
So
So it's relatively
Really
cheap,
cheap.
compared to.
yeah, and there's tons of other devices. So you have diodes, you have force sensor. I mean, they have tons of different types of little micro embedded
Yeah.
systems that you can actually attach on your own little breadboard kit and get up and running.
Okay. Looks like a nice prototyping board.
Actually, it was.
Yeah.
So
Okay. So that's. I think we covered all these devices, right? Device.
yeah, we covered all the devices. Yeah.
Device. Do you want to show maybe some demonstrations of your
Yeah.
prototyping board working with the Raspberry Pi on a computer?
Yeah. Well, maybe explain a little bit about what I have
Yeah.
here. So I'm going to lift it up a little bit. Hopefully, no cables will fall out. And I'm going to put
Let me help you.
I'm going to put my glasses on so I can see what I'm looking at.
All right. I got the fragile cables.
So
Okay.
basically, in here we have a force sensor and a simple resistor to catch the rise of the basic resistor. This is what this is as well. So force pressure sensor. We have a cobbler, this guy right here, that just is a contraption that allows me to feed the breadboard off of the Raspberry Pi, the GPIO port, to this, and then put it onto a breadboard. So then I can then do my little wiring instead of soldering. So it actually streamlines your fun, so
Yeah.
to speak. So again, this is your serial tip, so to speak. You can connect it to your computer, and then you can actually bring up Minicom or some kind of a terminal tool that you like that gets you your serial tip into access. Over here we have a light sensor, or a photocell sensor, just light intensity. Again, more resistors, a diode. This guy here is basically an LED strip. It's communicating across the SPI bus. Then on top of the Raspberry Pi, you probably can't see it, but there is a Raspberry Pi underneath. This is called a shield. So Raspberry Pi creates shields, TI creates capes, whatever you want to call it. Batman and Robin, I don't know. But anyways, so we have an LCD plate here that is provided by Adafruit. So you basically get out your soldering iron, you put all the pieces together, you solder it up, and off you go. So on this, it has a contrast sense adjustment for the display. It has some buttons, and it actually has this little guy here. And this is a GPIO expander. So basically, it gives you more GPIOs to use for your development, instead of using your GPIO off of the main board itself.
Cool.
So it just gives you more,
Yeah.
which is pretty cool. So I can go into showing this quick little demo on it if you want.
Sure.
or-
Yeah.
So we'll bring up. So we'll bring up
Yeah. You're on.
3.
Yeah. Sounds. No. 1.
There we go.
No.
No?
4. Yeah.
There we go.
Okay.
So I think Steve was showing a little bit about FTP and STP and trying to get bits and stuff to the Raspberry Pi. I'm using NetBeans 7.4, an advanced version, which has a cool feature inside it, which helps you remote deploy your application.
Sit down.
Which helps you remote deploy your application actually to the Raspberry Pi from the GUI, from the NetBeans environment. So I'm just going to go quickly kind of and just explain a little bit about it, and eventually you will probably see this in your NetBeans version. So inside here, what helps me be able to actually execute my test cases is inside this run command, there is this new thing called manage platforms.
Hey, wait. I don't have that.
Yeah, I know. It's called an advanced version. That's why I was.
That's not fair.
So inside this managed platform, you actually can create you set up your environment of the different types of devices. So there is a bunch of signage out here, a bunch of different devices. You actually can set up all your signage systems in here and call it machine, sign 1, sign 2. So if I click on my managed platforms, you see we have over here remote Java SE. So I have a Raspberry Pi, which happens to be the one in my office, and then this one here called the Demo Pi. So you can create signage 1, signage 2, signage 3, and just remote deploy to the system. So
Cool.
you build it and then to push to all the systems. So it's a pretty cool environment to help you deploy. It also deploys the profiles JRE, which is in JDK8. So you can actually take JDK8, eJRE, you download it onto your Mac or your Windows or your Linux box, however it is. You bring up your NetBeans environment, you tell it where it is, and then the GUI comes up, and basically you set up your environment, you say what components you want to add in, and then you say push, and it connects to your Pi, pushes the JRE down, and then the next time you go and start doing your application development now, when I want to run an application, it then just connects over to the Pi and off it goes.
Cool.
So this is basically a simple little example using a force sensor. Very simple code. I mean, up at the top, you notice there's no Pi for J here. What we've done inside of in this code here is we created this little Java SE platform class, so to speak. And basically what this does is it sets up all of the wiring underneath the hood, so you don't have to pay attention or worry about how do I attach to this SPI bus, or how do I attach to this I2C bus? How do I initialize the thing for what I'm doing? So
So it abstracts away
it
that.
basically abstracts away that for you. So which leads you to basically just doing your per Java code. So I have my LED strip, which you see out there.
Yeah, he's dangling.
I have my analog to digital converter sensor program, which takes the I2C bus, takes the information from that, and then feeds it back out as a result value.
Cool.
So let's just go execute this one. But I won't debug it yet. So notice it's logging into my device
Yeah, that's pretty nice.
and connecting to the device.
You're not
and
sitting
now,
there in SSH or SFTP doing it by hand.
yeah, and so now it's just running.
Yeah.
And so you see the values, it doesn't really look like it's doing anything, but actually it is. As I squeeze on the force sensor, the values go up and down. So relatively cheap device, with the Raspberry Pi, $35 and $1 for the sensor and $10 for the analog digital converter and $5 for the breadboard, you're off and rocking pretty quickly.
Cool.
So that's this program. So that's just a force sensor. So I have another one. I'll go to the photocell sensor. So this one here, same kind of plumbing, kind of makes it nice and easy for you. So you just get right into doing your actual code, which is I want to read some value and then process it and do something with it, which is, in this case, you notice the lights didn't go on the last time. This time, I'm actually reading the value from the photosensor, detecting the light intensity, and based on the light intensity, it turns my light on or it turns my light off.
Oh, so the light is now off. Let me hold it up.
Yeah. And as soon as I put my hand down,
Oh, wow.
it's a miracle. So, I mean, it's very, very basic stuff.
So these are the same lights used in the chess table.
This is the same
Right.
lights in the chess table.
Okay.
Yeah. I actually stole the parts for my demo. Considering I built most of the stuff too, so I got to get to play. So I have another demo. So on this thing here, we have a Pi plate, and this is where I don't know how you want to
The
show.
LCD screen.
Yeah.
I'll
So do you want to do?
angle it, and you can.
All right. Cool. So on the Pi plate, you can just do kind of some of the similar text. This is actually a VGA display, but this here is just an LCD
this
screen.
guy right here.
Yeah.
Yeah.
Again, same plumbing, and just taking and just sending random different types of text to the screen.
Do I need to press anything? Or, oh, there he goes. CHA
Yeah, it's
Java Pi rocks. That's
I
pretty
just
random.
went through a random sequence of just types of text and different things that you can do with it.
Can I press a key?
Anything but the select key. So yeah,
Anything? Okay, I got it. Left, right, down, up.
and then you can hit the select button at this point, and that demo's done.
Okay.
The point is now you take buttons, which would be typically on a GPIO. Again, that expander that I was talking about on the bottom actually abstracted. You're not really talking on the Pi's GPIO. You're actually talking on the expander's GPIO for those buttons. And again, we abstracted all of the calls, but it's the exact same, you set the input or you set the output of the GPIO, and you can actually get the values from it.
Cool.
So that's that one. The next is, wait, there's more. Hang on. Where is it? So, we have the data, or we have a force sensor, we have the light sensor, but now can I do something with it? Because I just spit some text, but
Yeah.
why don't I
sorry,
actually...
I'm going back. I'm
You're going
being
back
the
over there again.
device
So-
showcase again.
So this time you're actually... Yeah, cool.
All right, so what's supposed to happen?
So it's just showing the light intensity, and if you squeeze that little force sensor,
Oh, yeah.
the force sensor. So this is just basic application that's just taking the data and putting it to the screen,
That's the best I can do.
the LCD screen. Yeah.
And the light. Oh, no light.
Yep. And so
Light.
it just goes up and down. So
No light.
very simple stuff. The code for this, again, I create the same SE platform. You can put it down now for a sec. Same SE platform instance. I create an instance of the plate. Again, we abstracted the handling of the whole plate. We abstracted the extender for the GPIO. And then just create an instance, and off I go and read the data and push it to the screen.
Cool.
So
Okay, so
one more.
one more?
Well,
Okay, let's do it. One more.
okay, one more. All right. So
See how much you can have fun with the cheapest board on the table with the little, all the devices and sensors hooked up to it? That's the most fun one.
oh, hang on, I forgot. So now I actually have to sit on my, of course, control. Okay.
Serial tip got knocked out.
This is the painful part, starting Jetty service up on a Raspberry Pi. It takes a bit of time. But what this is doing, this is a basic application. I'm going to go through it and I'll show you the app. It's a basic RESTful web service that is actually running on the Raspberry Pi. Just a basic web template. Back to the project. So again, in here, I'm basically creating the same Java SE instance. I'm inside a web application. I have a method called getReading on a particular port number. So I can say right now the force sensor is actually on A0, so I'm actually passing it A0 port. It could be any port, and so I'm passing that value, and then the data will be actually sent to a browser, and you can see that data. So hopefully it's up. So that's a repeat. And again, simple RESTful web service running on a Raspberry Pi and taking data from a sensor and pushing it out. So that's just a static-based example of that. So, I guess it wouldn't be a Steve demo without FX somewhere in this thing. So I figured, again, the same thing with FX. So we kind of visualize the data in a meaningful fashion, so to speak.
Yeah, yeah.
We're asking...
Oh, charting APIs.
We're asking for the data.
Nice.
And that's about it. It's pretty generic stuff, but
Yeah.
again,
yeah,
it's a RESTful
cool.
web service that's it's consuming the RESTful web service data and being sent to the application, which is actually running on my Mac itself.
Nice. Do you approve, Jim? You like that? Absolutely. All right, that gets to Jim Weaver's thumbs up.
Yeah, so I think FX.
All right, so we should show our Duke pad.
All right.
You ready?
Yeah, I'm going to shut this down first.
Boop. I gotta guess again. DVI, HDMI. Okay. So we're gonna talk a little bit about the Duke pad device. So this is something which the team in Santa Clara, Gary, Jasper, who else was Duke padding?
Richard.
Yeah, yeah, Rich, of course. Anyway.
Pretty much everybody. Anybody that we could grab in the hall.
Yeah,
And
we give them a
throw
soldering iron
throw a
and
soldering
tell them.
iron at them, and they were actually helping doing a lot of the building.
So this is one of the early prototypes of the design where it's actually layered plastic that's cut on a CNC machine. And this is the actual plastic cut out with, I think there's some sort of paper or something they put over it
Yeah.
when it's initially laser
It's
cut.
it's like a plastic, very thin
Yeah,
material.
like a plastic film that
Yeah.
you peel off later.
Yep.
And here are some of the hardware components, like this is the USB hub, the HDMI, the chalkboard electronics HDMI to Pi converter, or to screen converter. This is the power supply we used. We just used an off-the-shelf USB power supply, which happened to supply, I think this was like
12,000 milliamps.
12,000 milliamps?
Yeah, that's a really
Yeah,
powerful
yeah,
battery.
a lot of power.
Well,
from-
as Steve was saying, the reason why we chose this,
yeah.
I mean, we're not trying to build a production level system. We're trying to build a system for the common Joe, so to speak. Yeah, it may be a little bit more expensive. I could have basically took all the power, the USB hub, all these devices and put it on a specific board like one of these expanders, if anybody ever decides to do something like that. Then it would have been made this a lot easier and actually way cheaper to build. But anyways,
Yeah,
we're back
but
on
I
the
mean,
more of the
use
parts.
something bigger and easier, and then you have less issues when you have additional power requirements, or you add like an HDMI splitter or something random inside the box.
Or GPS.
Or GPS, yeah. Okay, that's part of the Pi buildup, the case. The frame of the Pi with the different devices, the Pi camera, the accelerometer, and the USB hub, plus the battery popped in there.
Yep.
Oh, that's almost fully assembled, minus battery.
And wiring.
And wiring. All right, there's more of the wiring, I think.
Yep.
Later shot. Oh,
Yeah,
and there's the actual lab. We took over one of the lab rooms in Santa Clara and made it the official.
we took over one of the VPs, his actual conference room for about, 3-4 months
Yeah.
of nonstop
yeah.
doing type of development.
I don't think they want it back, though. It was pretty grimy when we left.
Yeah, we had to have cleaners come in and clean the rugs because the rugs really got messed.
Okay, so you can find out more information on the wiki, but let's actually show the Duke pad since we have one of these guys here. Okay. So here's the Duke pad. Oh, that's warm. It's been sitting for a while. Can you zoom in on the back of the Duke pad? Okay. So this guy, you can see all the hardware. It's actually nice acrylic layers and all the components in there. This is the horribly hacked one. We took the battery out and we replaced it with an HDMI splitter, so we could maybe be better for presentation purposes. So the output of this is going to the screen. Can you pop the input to the HDMI?
Which, 2?
I don't know. Try 3 or 4.
3?
Yeah, there we go.
go.
Okay. So now you're seeing exactly what's on the screen here for the Duke pad. So, come on, Duke pad. Oh. Log in. This is good practice for the keynote tomorrow. Come on. So sometimes the cables inside of it get a little interference since it's not properly shielded, or your hands are wet. I think that also doesn't help. You want to try? See if your fingers can do it.
Nope. It's going to make a nuisance of us. Nope.
All right, I got an idea. Pop. Okay. If there's interference, that'll reduce it. Okay, so I bet the other thing you guys were interested in seeing was the boot sequence for it. How do you know it was really even on at all unless we boot it from scratch?
There you go. And
So
it boots up super fast.
Yeah, almost. It's pretty good. So you can see the Raspberry Pi boot screen. Beautiful Duke pad. I think you guys added part of the splash as part of the OS boot, right?
Yes.
And the other part is when the JavaFX, it's actually a full JavaFX user interface which runs on the Duke pad.
You know, this is a user perception. You think that it's already there, but it's still lifting.
Yeah, and then this is the actual JavaFX boot now happening, I think. It's not supposed to be black, though.
I think one of the things that we learned in developing the DukePad is
There it goes.
it's fun playing with hardware, but when you have deadlines and you have to produce on a stage and make it bulletproof, all sorts of things play into making things just difficult, like what happened to Steve just 2 seconds ago. Sometimes the display or the USB bus kind of just goes out from underneath you. The Wi-Fi doesn't work. Or what happened, the Java one with Ethernet?
Yeah.
Is not playing
Oh,
with you?
see, now we're getting, I like this, we're getting consistent behavior. Right, like intermittent behavior is very hard to deal with, but I can deal with consistently not working.
Hang on. Hang on. Oh, figures.
Is that USB loose?
Oops. That wasn't supposed to happen. Usually I have the USB for the touch on the top,
Oh, is that backwards?
and when you do that, then you can just pull out the USB on the touch. And sometimes, but not this time.
Tweaking the USB on the touch actually
Yeah.
works.
Unfortunately, I guess we can't show it.
Well, no, not today apparently. Let me take a quick look at this connector too, because this one looks loose. I'm going to firm that one up. Oh. Nope, no touch.
All right.
All right, so if you build one of these yourself, then you can actually play around with it and get it working. And we've open sourced all of the code. So you can try the DukePad yourself if you go to the other input. There we go. If you go to the DukePad website, we put a short URL, j.mp/DukePad, where you can get info. So it has instructions on how to build the case, tells you what software to download to get Java running on it and the distribution. Also, we open sourced all of the applications and stuff running on the DukePad itself. So you can actually play with the DukePad applications on the device. All right, so thanks very much, Gary,
You're welcome.
for joining us. Give him a round of applause. And the next thing we're going to do is we have a special guest who was part of the hackathon that's been going on the past couple days. Is going to show us some of what they've been doing at the hackathon, give us some insight into what sort of cool projects which they've been working on. And it's going to show us a live demonstration as well. I think we have people scrambling on stage, which means that we'll have cool stuff to show. Do we have a extra handheld mic that we can use?
Do we have the possibility to have a video output there?
All right, thanks. All right, so I'd like to welcome onto the stage Vinicius, who is the Globalcode founder, Yara, his wife, and Thomas.
My name is Thomas. Yes. Hello.
Okay, welcome. Here you go. You and Vinicius have to share.
Yes. Do you think we can put the video cable here on his notebook?
It's possible.
Awesome. Okay. Let's see. So, first of all, thank you very much, Steve, for opening this space here in your talk. We have been hacking during yesterday, the entire day, and also today, and we came up with some very interesting hacks. We have been receiving people that are just wanting to kickstart their Raspberry Pi project, but also people that already have more experience. So we end up with applications that were using the distance sensor, the camera, the MQTT, and lots of other technologies, the relays turning on and off, some people trying JavaFX. So I really encourage you guys to, whoever has a Raspberry Pi on your shelf, And I'm pretty sure most of you, not most of you, but lots of you have a Raspberry Pi sitting at home and waiting you to just do the first steps. And it's not complicated, it's easy. Just take care because it's kind of addictive. You see these guys here, they can't stop doing this crazy stuff. So if you have your Raspberry Pi, take care that you can be the next guy to be here on the stage making your demo on Raspberry Pi. Let's go.
Okay.
Let's go there, Thomas.
A warm welcome from my side. My name is Thomas. I come from Austria. I'm a normal DevOps NT, but Vinicius pushed me in this room to give a short presentation. I'm not prepared. You see it with the red brill. Video isn't working.
That's a special effect. We paid extra for that.
But hopefully my demo is working. I do Java EE and SOA in the banking domain in my normal life, and in my spare time I'm doing some hacking with Raspberry Pi. In my demo I'm using the MQTT protocol to communicate between the Nexus 7, the Raspberry Pi, and an attached Arduino. So I have set up a micro enterprise service bus, because for the integration job I use Java 8 on the Raspberry Pi on Apache Camel. Apache Camel provides a default component to publish and subscribe to MQTT topics. Furthermore, I use the Welt container to use CDI stuff, because I'm used to program in a CDI style. And one thing I have installed on the Raspberry Pi was the Mosquito server. It can very easily be installed on the Raspberry Pi, sudo apt-get Mosquito, and then it's running on your Raspberry Pi. As I met Vinicius these days, he introduced his Things API. I downloaded it tomorrow morning, and I tried some integration in 2 or 3 hours. So that's the result of our...
How many hours did you sleep this night?
Enough. I have 2 children. One is 3.5, and the girl is 6 months. I'm awake. Really have a lot of sleep these days. Okay. First of all, I would show you some code, and then a live demo.
Yeah.
Okay. Please don't look too close on my code. It's hacking. It's not very good code. It's a Hello World style.
Have a seat.
Okay. In this code, I simply bootstrap the Welt container, and I initialize a container class that can do some shutdown afterwards. But the interesting thing is my Hello World integration, where I initialize my roots. I have 2 roots, camel roots, one that is listening on a file directory. It's my simple root. And today I was implementing a things root that listens on MQTT topic and processes this request and connects to the Arduino that is, uses the serial port. Here is the root builder. It's normal camel style. Here's the default MQTT component I use. I have a broker address, a topic that I'm subscribing to, some logging stuff, and then there's the things bean. As you can see, I'm using the CDI integration of my beans. The things bean is only named, and this is the things I learned from Vinicius. He has a very intuitive API that I can send commands to the Arduino via the serial port. It's no rocket science. It's a Hello World thing I did in 2 hours today. Hopefully the demo works, but I must not in shame, because the Duke board doesn't work too. Also, I have nothing to lose today.
Yeah, that's true. You know, engineers working for 2 or 3 months on something which doesn't work when it's supposed to, and if yours works after a day of work, we know who wins.
Okay. This is the command line that comes with Mosquito. You can on the one side publish the topics and subscribe to topics. Here is the protocol I use from Vinicius. It's very simple and easy to understand. This is the speaker component on my Arduino board, and these are the parameters I can pass to it. The 0 says turn the speaker off, and the 1 says turn the speaker on. Here, please turn it off.
That's the most sophisticated and advanced speaker in the world, right?
I
You use
can-
all this technology to turn on a speaker. But this is very important because this is a use case of very corporate technology. This answers what lots of people has been asking us about. Is this technology, can be this used in real world application, or how can I leverage my Java EE background to do this kind of things?
And to top this a little bit, I have my Nexus 7 and MQG client installed on it, and I can send this message a second time, hopefully, publish, and it works. And I turn it off.
Nice.
As you can see, I used very basic things, some knowledge I brought with from my company. It was very easy to put these things together, and I have developed a micro ASP on a Raspberry Pi.
Cool.
And my API just won a MQTT plugin, yeah? Thank you so much.
Okay.
Very nice. Congratulations.
Thank you.
All right, so in addition to this, they were doing lots of cool projects. I grabbed some photos while these guys were busy hacking at the tables. And you can see, you know, some of the different things which they were building up over the past couple days. So very cool projects, and thanks.
Oh, we have more.
Oh, more?
We have more. We
More?
have one more very fast project, okay?
All right. Go.
Is it okay?
Yeah.
Okay, I would like to invite Benjamin, a student from university who was hacking here with us, just to give a brief description of what you were doing.
Hi, everybody. I'm Benjamin. I'm a student of the University College of Aalst. We tried applying fuzzy logic because we are doing a course of artificial intelligence at our college.
Okay, can you guys move a little to the side? Camera. Yeah.
So we started with creating a Java FX application and trying to get data from the sensor, the distance sensor, and it worked actually. That was amazing. It was amazing to learn how to work with all the components. Very interesting. I learned a lot with the Raspberry Pi and Arduino and the relay. They are finishing the project. We're still working there. So I thought that it was very interesting to see a student that is trying JavaFX for the first time, that is applying fuzzy logic in a different context. So congratulations and thanks for coming and joining.
All right, so thanks very much for showing us some of the projects which are going in the hackathon. You want more? One more.
One more.
One more.
Just one more.
All right.
This one is to
I
realize...
should learn. So I've been to Brazil a couple times. And I should know from hanging around these guys, like you have a party, and they say come at noon. That's when they start preparing for the party.
Yeah.
And then like 2 or 3 or 4, that's like when everything's in full swing. So
Yes, and talking about
3,
party,
we're good at 3.
Talking about party, this demo I did to realize my dream, which is to drink a beer during a presentation. So here we have the embedded panel that we build for the hackathons, and we have many sensors that they are shared through the REST interface. So if you are learning IoT or you are learning embedded, you can just consume a REST service to use a sensor. And we have here alcohol sensor. So I would like to try to test the alcohol sensor with the audio system and voice recognition from my cell phone. So I'm going to ask in Portuguese to my cell phone if I drink. But since my English is so perfect, it can't recognize my English. So I will ask in Portuguese if I drink. I will ask Java, did I drink? And so we will see the result. Java, eu bebi? Oops. Sorry. Let me try again without the voice. I'm the wrong network. Sorry. Simple problem to solve. Okay. Come on, I'm getting nervous. I am connected to the right one. Let's try again. Java, eu bebi? Come on, guy. Please breathe near the panel. No, you didn't drink.
Wait. We're chugging beers on stage here at DevVox. Is that okay? Are we breaking any laws?
Where's the British boss? Please breathe near the panel. I know that you drink. That's it. Technology, fun, and beers. That's DevVox. Thank you.
All right, excellent. Thanks, Yara. Thanks, Vinicius. So, to close things out, I would like to invite our final guest presenter, Simon Ritter. Welcome, Simon.
Hi.
And I hear you've done something fancy with your car.
Yes, that is what I have been working on. Hang on, let me just move some of this out of the way. Okay, just make sure that, because, oh, good. I got a grey screen of death from my Mac earlier on. I wasn't expecting that at all. Right. Good idea, yes. Yes, save me from myself. Okay, so what I'm going to do a talk about this tomorrow. So I have a whole session on this tomorrow. But I thought it would be interesting just to give you some details about what I've been working on. One of the things that I like to do is I like to try and find interesting ways to use technology. If you've seen some of my presentations before, I've tried various different things in terms of adapting technology. And what I did this time was I thought, why don't I try adapting technology and the Raspberry Pi to my car? Because there's some interesting things that you can do with your car. Now, what I really wanted to do with this was to get more information. So who here follows Formula One on the TV? Yeah, so there's a fair number of people. Formula One's one of these things where there's a lot of technology involved, and it's quite exciting when you watch it because they show you a lot of telemetry information. As you can see people going around the circuit, you can see how fast they're going. You can see the number of revolutions per minute of the engine and various different data like that. And I thought, right, I want to try and do something like that with my car. And so let's find out, what the engine's doing in terms of how much torque is being generated, how much power, maybe get information about my driving style so I could adapt my driving style to make it better, that sort of thing. And also looking at the G-forces on the car. So Angela showed the idea of using an accelerometer and connecting it to the Raspberry Pi. So I thought, well, let's use one of those as well and have some information there. And then the other thing I thought was, well, let's record all the information as I'm driving around, and then I can review it later and I can decide, you know, where I was doing things wrong and where I was doing things right, and improve my driving style. So the first thing that you need is some way of communicating with the car. And there's this lovely little box called an ELM327. Anybody heard of this? Okay, a couple of people. You can buy it on eBay. It's really cheap. There's two different versions you can get. You can get a Bluetooth version and you can get a Wi-Fi version. And if you look under the dashboard of your car, because pretty much any car since about the year 2000 in Europe has one of these things, there's a little service port which looks a bit like a SCART socket on your TV. And you can plug things into that. And if you take it to the garage, they will actually plug in a machine to that, and they'll be able to find out if there's any faults on your car that have been recorded in the system. So you can buy one of these little boxes, and it plugs into the service port, and then, in the case of the Wi-Fi one, it creates like a little Wi-Fi hotspot that you can then connect to, and you can send messages to your car, and you can get data from your car. Now, there's two different types of information that you can get. One is the basic set of information. There's a thing called OBD2, onboard diagnostics. And that's really a simple set of data which is primarily designed to allow the garage to determine how efficiently your car is running. And therefore, it's about emissions control and the exhaust gases and things like that. So you can also interrogate what's called the CAN bus. And that's where you get a lot more data about what's actually happening in the car. I won't talk about that too much now because, like I say, I'm going to have a whole session on this tomorrow. But the idea with this is to say, okay, I've got a little Wi-Fi hotspot. How do I then connect that to my Raspberry Pi? So I put a Wi-Fi dongle into the Raspberry Pi using the USB port, and I set that up so that I could do point-to-point communication with the ELM327. And then it's really just a matter of sending commands in the form of a simple message to say, okay, this is what I want to get in terms of information, get the information back. And if you're very brave, you can actually send messages to the car and actually put those onto the CAN bus, which is actually controlling the car. So in theory, you can override the signals coming from different sensors and things like that, which I haven't done yet because it's potentially very dangerous. But, you know, it could be interesting to see what you could do with that. I've actually seen, there's a great demo that I saw where somebody had done this, and they had it was a Prius, Toyota Prius, which had the automatic parking system. And the automatic parking system could therefore control the steering, as well as just the throttle and the different parts of the car. And so they had a person sitting in the car with a Game Boy and actually driving the car, because they could control the steering motor, they could control the throttle, and they're actually driving the car with a Nintendo Game Boy. So, interesting things you can do with this. So, in terms of putting this into my car, I wanted some sort of screen that I could have the display on. And again, I went on eBay, and I found this particular thing. Now, Stephen talked about the Chalk Electronics screen that we used in the Duke Pad. And they were going to do a 7-inch version. They had some production problems. And so I needed something that I could use straight away. And I found this device on eBay. It was about it's just over $100. And it's got an HDMI input. But it is actually designed for cars. So it has what's called a 2-DIN size fitting. So it's basically the size of two old-style entertainment systems. So if you've got a radio or a CD player or something, it's the size of two of those in older cars. And what you get is HDMI input, and then there's a USB output, which is the touchscreen implementation. So you can then get the data from the touchscreen. Now, getting that to work was a little bit tricky, because when I plugged it into the Raspberry Pi, the actual touchscreen part, it recognized the fact that it was a touchscreen. So I got a message on my D-message output, and I could see that it was an eGalax Inc. device. And it created two devices in the /dev/input directory, event 0, event 1. Now, when I tried to use it with JavaFX, it didn't see any input signals, so I couldn't control anything. But if I used X11 and the standard desktop, that all worked quite happily with the touch system. So I had a chat with the engineers in the JavaFX side of things, and they said, well, it's always looking for events coming from event 0. And clearly what's happening in this case is that the events are coming from event 1 rather than event 0 for whatever bizarre reason. So I thought, okay, well, chatted with them some more, and they said, well, we could do a special build of JavaFX for you, which uses event 1 rather than event 0. And I thought, okay, well, let's see if we can find a different way of solving it. And so in the end, what I did was I thought, okay, well, we can actually solve this problem in a simpler way, which is simply to remove event 0 and then do a mcnod and recreate event 1 as event 0 with the same major and minor device numbers. And then you get the events being sent to JavaFX. And that actually worked. So I had a little script that I wrote that ran at boot time, and so it all actually works, which is good. Now, this is the sort of overall architecture, if you like. It's a rather grand word for what is quite simple. I've got the Raspberry Pi. I've got the USB Wi-Fi dongle, which communicates with the ELM327. I've got the touch screen, which is plugged into the HDMI port. I've got the accelerometer, which is plugged in through I2C into some of the GPIO pins. And then I've also got a 5-volt to 12-volt, or 12-volt to 5-volt converter, so I can actually plug it directly into the power of the car, which is 12 volts, and have that power the Raspberry Pi for me. And then if you look at the insides of my handily manufactured device, you find this is what I get. Now, there's a couple of things about this. One is the fact that, as you can see, there are pieces of wood in here. This is very good, because I'm a firm believer that any good software project should involve woodwork. The other thing is, as you can see, I had a little trouble sourcing a short HDMI cable. So I've got a 1 meter HDMI cable, which really needed to be about 4 centimeters. And I had to sort of loop it round a few times and then kind of stuff it in. But eventually it worked, so that was good. And then I managed to mount the Raspberry Pi on the back of the screen, because there was a couple of light holes that I could use, and I sort of, with a bit of perspex and some bolts, it actually seemed to work. The accelerometer was fairly straightforward. Angela's already talked about this, so I won't go into any great detail. As she already said, this is a nice little device. It's not fantastically cheap. It's about $50, I think. But it does give you 9 degrees of freedom. So you get a 3-axis accelerometer, you get a 3-axis gyroscope, and a 3-axis compass. So you can monitor pretty much all kind of movement. And it's also got some onboard processing that will combine the values from those different sensors and therefore give you more accurate positioning data. Didn't actually need that for what I was doing, because really I was just interested in the acceleration in any particular direction. I thought about using the compass, but it's a little bit more complicated to get the data out of the compass, and I didn't have time in terms of getting everything finished. So this is the kind of code you end up with for the accelerometer. Basically, you use the I2C bus. You have to determine which address on the I2C bus to use. That's highlighted in blue there, so it's 68 hex. And then you basically say, okay, write some bytes to it, say, I want to start reading data from it, and then set the configuration, because the accelerometer will do, I think it's 2G, 6G, and 4G, I can't remember either, but there's different sort of scales that it will actually go to. And clearly for my kind of driving, I didn't need a 6G accelerometer, because I don't think I'm going to pull 6G either sideways or forward or backwards. I certainly hope I don't. 6G deceleration would be like I'm running into a brick wall. So then I came up with trying to build a user interface for this. And one of the key things there is to keep the interface simple. I was talking to Vinicius about this, and oh no, it was Gerrit. Is Gerrit here? No, okay. I was talking to Gerrit about this, and he said that with JavaFX running on the Raspberry Pi, you need to keep the number of nodes in the scene graph small, because if you start getting very complex scene graphs, it does start slowing down. And so I came up with some simple ideas for like a bar graph that would change over time, and that simply used 3 nodes for the outer rectangle, the inner rectangle that shows you the value, and then a little red line which shows you what the highest value you've had is. And then as additional optional nodes, you can put the labels on it to see what's actually going on. Nice thing about this as well is that because you're driving, you don't want to have complicated displays. You don't want to have lots of numbers where you have to try and read those things. What you really want is something that you can glance at and actually get some idea of what the value is. So that seemed to work quite well as well. In terms of the user interaction, again, because you're driving, you don't want too many distractions. It's not like trying to, text as you're driving. So I tried to keep things fairly simple and use the touch screen simply as a way of changing from one screen to another. So I constructed a set of screens that would display different types of data. And then rather than having like a menu or some kind of complex system, you literally just touch the screen anywhere and that will change to the next screen. And by keeping the number of screens fairly small, you can loop through those and select which one you actually want to view without having to be distracted too much from driving the car itself. So that's kind of really what I came up with. One of the things I did want to do was, in my car, there's lots of buttons. And so on the steering wheel, you've got various buttons that control things like the hi-fi or the satellite navigation. And I did want to actually try and read some of the data from the CAN bus and use some of those buttons to control the interface as well. But I didn't, again, sort of ran out of time in terms of doing that. So the first thing I did was create a splash screen. And so I actually photographed the existing satellite navigation system, entertainment system that I've got, and then overlaid a couple of graphics on it. So I've got the Duke and I've got the Java logo. So I get a nice little splash screen that comes up. Then I've got some basic data. This is kind of things that you can get from the Elm 327. So you've got engine load, you've got the intake temperature for air coming into the engine, you've got the catalyst temperature, so you can see what the exhaust gases are going at. You can see the throttle position, because nowadays pretty much any car is fly-by-wire, so the throttle is not actually directly connected to the engine. It's just a potentiometer that sends a signal, and so you can read that information. And then you can also get the fuel pressure and see how much fuel is being pumped into your engine. And then sort of more advanced data, I took again the throttle position. This time I took the engine speed. And if you combine the engine speed with knowledge about the weight of the car and a couple of other things, you can actually convert that into the amount of torque that's being generated and the amount of power that's being generated as the car is going along. It also relies on some acceleration data as well. And then to give the acceleration data, I created a sort of more Formula One style of display where you can see the G-force that you're being subjected to at any point. And so you've obviously got left and right is the amount of G-force as you're cornering, and you've got up is the amount of G-force as you accelerate, down is the amount of G-force as you decelerate, as you're braking. And then the little line on the right-hand side was the up and down acceleration. So you could see as you're going over a bump or a speed bump, as the car actually moved. And then to give some more interesting sort of historic data, I also graphed some of these things. So here's a sort of a quick snippet of the throttle position. So you could see over time what's actually happening in terms of the throttle position. So what I'm going to do now, because that's the last of the slides I've got, I'm just going to show you this, actually, a demonstration of this. So here's my in-car system, which I've kind of, like everybody seems to be creating a sort of like a Duke pad. I've got the Duke Pad Mini, because it's a smaller version. Now, good, okay. So obviously I don't have a car here. So the data that I'm going to use is actually from when I did a test run, and as I was driving the car, the system logged all of the data into a simple text file. And I've got that on my laptop. So now the laptop is going to act as the car in terms of providing all of the data. So if I just, you don't need to see this because it's just running a simple listener. So that's now listening on a particular network port. And then if I run this, hopefully, we'll need to zoom in on that if we can. Hopefully what we'll see, that's it, good, yeah, great. Excellent. Yeah, takes a few seconds to start up. You can just about see it's in simulation mode. Connects to the remote host. And then after a few seconds of just waiting, there we go, get the splash screen comes up. And then hopefully we'll see, yeah, there we go. Now, what that's doing is playing back the data from the run, as I said. So you can see that the intake temperature will sort of go up and down a little bit because the engine was hot as I started, so then the intake temperature will drop a bit. Engine loads varying as we drive around, a couple of other things. And then if I just press the, it was the first one, there we go. So then that's giving us the advanced data, so you can see how the torque and the power output is varying, engine speed's varying. And then if we go to the G-forces, you'll see as we're driving around, we're going sort of left and right, and you can see the various sort of movements of the car in terms of acceleration and deceleration, also going sideways. And then you can see throttle position, and if we leave that running for a moment. So essentially what you're seeing there is, it's interesting as I analyze this later, okay, so I've really hit the throttle there. And then you can also see there's like power output as well, which I graphed just so you can see the power there. So really that's just, I had to find some way of getting out of the application because Control-C wouldn't be recognized. So I had to put like a big button to say exit. So basically that was the idea, was just to sort of allow me to interact with the car a bit more and get some information. And so if you want to know more about this, I'll be talking about it in a lot more detail tomorrow in the session tomorrow afternoon. But I certainly had a lot of fun actually building this. So thank you very much.
All right, so wait there a sec, Simon. I'm going to ask my other presenters to join me back up on stage. So Johan, Jim, Angela, Vinicius, whoever else is left in the building. Come along back. All right, so I think that's everyone. So I want to thank all of my co-presenters for their contributions to the overall IoT embedded talk. These guys put a lot of work into the demos, which you guys saw today. So give them all a round of applause. And thank you very much for joining the IoT talk. You can find some info about my blog and also the video stream I'm doing. And I would highly recommend watching some of the talk these guys are going to be going at Devox later this week. For example, Gary and Alex are going to do a chess BOF on the chess table. Simon will get into more details on his car informatics session. Angela is going to be doing a session on her Parallax device where she'll actually show some of the graphics using the accelerometer. Are you done, Jim?
I'm done.
Oh, you're lucky.
I'll be watching sessions.
And Johan's going to be putting Easter eggs in the signage, so watch out for that. So thank you and have a good evening.